Welcome to Cryptography session. Today I am going to discuss few topics under Unit 2. So these are all the topics available under Unit 2. The first topic is Mathematics of Symmetric Cryptography. And a common symmetric key cipher algorithms are SDES, DES and AES. So these three algorithms are come under symmetric key cipher, and a few block cipher mode of operations are performed. There is a possibility of doing multiple encryption mechanism under symmetric key notation. So those multiple encryption scheme examples are double DES and triple DES. And the implementation of symmetric key cipher algorithm is an RC4 algorithm. So these topics are available under Unit 2. So in the mathematics of cryptography, this topic is under a symmetric key encryption algorithm. So there are two different topics are available. One is called a general algorithm, and another one is a few notations which is available under symmetric key number system. In a general algorithm, we can able to find out a GCD of given two numbers. So we can directly apply a GCD concept for two-digit number. So if the number is given as 3-digit or 4-digit, it is hard to deduct the GCD of given two numbers. For that, there is a generalized equations are available. So those equations are come under a Euclid's algorithm. And we can able to find out the multiplicative inverse of another number that is solved by using an algorithm called extended Euclid's algorithm. In a modular arithmetic concept, there are two type of inverses are possible. One is where we can able to find out the additive inverse of a given number, and also we can able to find out the multiplicative inverse of given number. So these are all the generalized algorithms. These algorithms are the basis for implementing a symmetric key mechanism. In a symmetric key, if you want to take a key, the key should satisfy any one of this following criteria. So those notations are called groups, rings, fields, and we can able to do some polynomial arithmetic operations on those numbers. So these concepts are available as a basic mathematical cryptography which is applied in a symmetric key encryption mechanism. So let us discuss the generalized model, and followed by symmetric key encryption will be discussed later. If you take a greatest common divisor, a GCD of two positive integer is the largest integer which can divide both two integers. For example, I want to find out the GCD of 12, 36. So these two numbers are even numbers. So the common divisors are, we should check the number from 2 onwards. 2 is divided, 3, 4 like that. We should take those numbers up to the least number of given two integers. So these are all the numbers, and the greatest divisor is 12. So therefore the GCD of these two numbers is 12. So if those numbers are a two-digit number, it is possible to check to find out the largest of given two numbers. But if the number is given as a 3-digit value or 4-digit value, so these three notations are for the generalized notations. So any number, that means GCD of a comma 0 is a, GCD of a comma b is equal to 1. So this situation occur where a and b are relatively prime. So if two numbers are given and those two numbers are relatively prime, then the GCD of those two numbers is 1. Otherwise, if those numbers are not relatively prime, then the resultant value will be retrieved as the generalized formula of GCD of b comma a mod b. Here a should be greater than b. So on that situation only we can able to implement it. So these are all the given few examples for finding the GCD of two numbers. So GCD of 3 comma 0, so it is applicable to first case. So the answer is A, which means 3. GCD of 3 comma 7, so 3 and 7 are relatively prime, which means that those two numbers have a common divisor 1. So that is the meaning of relatively prime. So 3, 7 GCD is 1. And 12, 3, these are all not relatively prime because those two numbers are divided by 1. From this one, I am taking the greatest value as A, which means 12, B means 3. The formula is GCD of B, A mod B. So the B value is 3, A mod B means 12 mod 3, so the remainder is 0. Then this is applicable under rule 1, so the answer is 3. In this way, we can able to find the notations. For example, I want to find GCD of 36, 10. So how can we check it out? From this two number, the greatest number will be taken as R1, smallest number will be taken as R2. So here it should be R2. Then 36, 10, I am writing the quotient at left side and the remainder at right side. So the quotient is 3, remainder is 6. For finding the next number, I am taking R2 value as R1, R value as R2. So 10, 6. So these two numbers are copied to second row. Then find out the quotient value. It is 1, remainder is 4. Again, R2 value copied to R1, R value copied to R2. So 6, 4, quotient 1, remainder 2. Once again, R2 copied to R1, R value copied to R2. So quotient is 2, remainder is 0. Then once again we should copy R2 value to R1, R value to R2. Then if R2 value is 0, GCD of 2, 0, which is applied as rule 1. So the answer is 2. In this way, you try to find out the GCD for these two numbers. So one number I am giving here is a 2-digit number and another is the 4-digit number. So which one is greatest? You should take that number as R1, the second number as smallest number as R2. You do the same process. So this is the Euclid's algorithm. So Euclid's algorithm can be applied for finding the GCD of two numbers with these steps. Okay. Then the second topic is a modular arithmetic operation. We can do several modulus arithmetic operation. Here I am giving 5 different techniques. One is mod operator. Second one is finding the set of residues and equivalent values. So other name for equivalent value is congruence. And what are the operations performed in Zn? So addition, subtraction, multiplications can be performed. And also we can able to implement additive and multiplicative inverse. So let us discuss one by one. Mod operation, which means that if you want to find a value, a can be written as quotient into n plus remainder. Here n is modulus, r is a remainder, q is quotient. So I want to find 27 mod 5. So quotient is 5, 5 cross 5. So quotient is 5, modulus is n, that is 5. 5 into 5 plus 2, r is a remainder. So the answer is 2. 36 mod 12. 3 into 12 is 36. So there is no remainder. So the answer is 0. So this is the way we can able to find out the positive mod values. Suppose if the negative mod value is given minus 7. So minus 7 mod 10 means just we should add the mod value, modulus value to the given number. So minus 7 plus 10, it is 3. So this should be repeated until we should get the positive remainder value. For example, minus 18 mod 14. So it is a negative number. So we just add minus 18 plus 14. Again, the minus symbol is available. Once again, you do the addition operation. Minus 4 plus 14 is 10. So the correct answer is 10. So up to getting the positive value, we should do the same procedure. So it is applicable for mod operator. Set of residues. So it is described as Zn. So a set of remainder of positive numbers and those set of values should be less than n. If you take a set of reminders, all the reminders should be relatively prime to n, which means that if you are able to find out the GCD of those two numbers, you can get only one. For example, Z2, set of residues less than n is 0, 1. And if you combine 0 and 1, these numbers are relatively prime to n. So in Zn, there is a possibility of 0 also. If you take Z5, the less values are 0, 1, 2, 3, 4. So if you compare 5 and these numbers, so those numbers are relatively prime. In this way, we can able to find out Zn values. Congruence means equivalent value, which means 12 mod 10. The remainder should be 2. In this way, we can able to find any value. So that means the left side value and the modulus value may be different. So here I am giving the modulus as same value, but it is not necessary. You can able to use different modulus values also, which means that 12 mod 10, the remainder is 2. The same thing for 8 mod 3. So 8 mod 3, the same remainder 2 may occur. So like 7 mod 5. So in this way we can able to equivalent those values. So modulus means equivalent value. That means if you do modulus operation of any notation, that should have the same remainder. So that is the meaning of congruence. And operations means we can do modulus operation with addition, subtraction, multiplication. The formula is a plus b mod n can be rewritten as a mod n plus b mod n whole mod n. That is also possible. So 7 plus 14 in Z15. 7 plus 14 means 21. 21 mod 15 is 6. The same thing for subtraction. 7 mod 11. So it is minus 4. The answer is minus 4. Minus 4 is not in Z13. So minus 4 plus 13 is 9. So the answer is 9. In this way, we can able to do multiplication also. Additive inverse, multiplicative inverse. Additive inverse means, for example, a plus b. If you add those two numbers a plus b, and if you do modulus operation, it should have the remainder 0. So we can able to rewritten this equation as a plus b mod n equivalent to 0. Likewise, multiplication operation. A mod b mod a star b mod n, that should be equivalent to 1. So how can we find those notations? For example, I want to find out additive inverse in Z10. How can we find out? So these concepts will be discussed in next session. Thank you.